Some people want to know how come the board is upside down. Well, one reason the board is upside down is to help you diagnose the system easier. Like in this case right here, we've got it open, and I've also got the test point diagram, which is in the service manual. All right, so let's go over to mylinkdrive.com and let's look the test point diagram up as well as the wire diagram so you can kind of see where they tie in together. So we're going to go over to mylinkdrive.com, down to USA Products. We're going to click on it. We're going to go to M Series because that is an M Series unit. We're going to go to Outdoor Unit. We're going to scroll down here where we see the GL, so it's a MUZ GL. So in that case, it's a 18. So we're going to click on it. We're going to click on the service manual. We're going to click on the service manual again, right there. And then what we're going to do is we're going to scroll down till we find the test point diagrams. Or you can use the Control F, or I'm on a Mac, so it would be Command F, but I've already done it. So let's open it up here. Okay. So this is actually the test point diagram. So when you take the top of the unit off and you take that little piece of metal that covers up the board, this is actually what you see. So if you go into the service manual, this is what you're going to see. Right here it says back of the unit. If you scroll down just a little bit, this is the front of the unit, so it's going to be the front side of the board. So if you kneel down and look under the board, this is what you're going to see. Okay. So when we first bring voltage into the board, it's going to be over here at these 2 points right here. And we can actually look at the wire diagram and we can see what these destination points are. It's going to be like LD66 or LD20, I can't remember. But we'll look and you'll see what I'm talking about. Then voltage is going to feed up. It's going to feed over here to fuse. It's going to feed over to reversing valve. It's going to come through, go through the reactor. It's going to come over here. It's going to hit these 2 parts of the board right here. So if you had incoming voltage, your 208, 230, here on the right hand side of the board, but you did not have it here, we would, at that point, we would go into the wiring diagram and we could see what was going on in between. Okay, but let's say you had voltage here and you wanted to check your DC voltage, your high voltage DC. You would physically go over to this little negative mark right here and positive mark, and you should get anywhere from 260 to 370 volts DC. Now that's going to be relative to what your incoming voltage is, what your 208, 230 is. So the higher your incoming voltage, the higher your DC voltage. Okay. So once you check your DC voltage, if you have it here, then good and fine. Let's move on. But if you don't have high voltage DC, but you have line voltage coming in, then we need to figure out what the problem is. But now let's just scroll down a little bit till we get to the front of the board. Now we've made it easy, or Mitsubishi has made it easy. They put all your thermistors up front of the board, and they'll be color coded, so you can just figure out which one it is. Like this defrost temperature thermistor right here, or the discharge thermistor. They're right here at CN641, and they're both together on one connector. So you would just unplug that connector, and you could take your resistance on each one of them right there. But if you need to check your ambient temperature thermistor, you just come over here to CN643, you'd unplug it and then take your resistance. Okay, so that's that. And then of course, if you want to check your LEV, the resistance there, then you could check it there. And in the service manual, it's going to give your resistance on each type of thermistor that you have. Okay. And so that's the test point diagram. Now let's go over to the wiring diagram. Let's look at it. Okay, so here's the wiring diagram. And right here is your L1, L2. That's your power coming in. It's going to jump down to S1, S2. And that's going to feed inside. But it's also going to come over here on this blue and brown wire. And it's going to feed up to LD61 and LD62. So that's those 2 points on the test point diagram on the back of the board that we saw, right? So we can take voltage right here. That's going to give us our 208, 230, okay? Then we feed through, we feed up. One leg right here feeds into this one fuse, and that's F701. And what that 701 is going to do is going to feed over, and anything that's 208, 230 inside that unit, like your pan heaters or your reversing valve, is going to feed off that fuse 701, right? So if we were in heating, in this case, then our reversing valve would actually be energized. Okay, so if we was in heating and the outdoor unit was in cooling, we would check voltage at CN721 on the back of the board at the solder joints. And if we didn't have any voltage right there, because on this particular unit, this unit energizes in heating, right? So if we was in heating and it was blowing air conditioned air, one of the first places we would check would be the connector on the back of the board, or the 2 solder joints, to see if we had 208, 230. If we didn't, then we could go over to 701, fuse 701, and check it. Okay. If that fuse is good, then we need to figure out why we don't have voltage at the reversing valve. Okay. And so now that second place that we saw 208, 230 was on LD70 and LD66. Okay. So we would see it right there. If we didn't have voltage here, but we had it down here at L1, L2, then something's going on with our board. Okay. So we would probably have the board bad at that point, because this little relay right here was probably bad. Okay. We've got a couple other fuses on that board. We have fuse 901, and what that's going to do, that's going to feed the fan motor, right? So if we didn't have voltage at the fan motor, we'd check that fuse 901. Okay. So that's pretty much it on the wiring diagram. And then there's 801. So there's another fuse, and that's fuse 801. But anyway, so that's that. Now I'm going to go over to the refrigerant circuit and show you that. It's right here. So you would think that with Mitsubishi, all the units would either energize in heating or all of them would energize in cooling. But we do have some units that the reversing valve energizes in cooling, and we have some that the reversing valve energizes in heating. Well, in this particular case, this GL18, come to the refrigerant circuit, or the refrigerant diagram in the manual, you can actually see right here it says RV coil, heating on, cooling off. That means that this coil energizes in heating, and it does not energize in cooling. Like I said, we do have a couple units that actually energize in cooling, so you need to come to the manual if you're having a reversing valve problem and find out, are we energizing heating or cooling? and then check it.
Which is right here. So that same points, those same points on that test point diagram is right here. So this is where your incoming voltage would be, and this is where your high voltage DC would be, right here and right here. So, and then if you want to know where the misters are, you would just go back to the test point diagram right here. If you wanted to know where the defrost mister was, right, it is CN641. So you go right here and you find CN641, which is right here, and then you would go underneath right here, and you would see that it's this blue, it's this one right here. Now there's two different thermistors right here, and how do I know which one is which? We go back up to the test point diagram, and we see that your defrost temperature thermistor is on the left hand side there, and over here your discharge temperature thermistor is right here. So the black one right there, the two black wires, would be your defrost or your discharge temperature thermistor coming from the compressor, and this would be your defrost temperature thermistor coming from the coil. But that's how you would know. And of course, if you have the outdoor heat exchanger temperature thermistor is CN644. Find it right here, CN644. We go directly underneath it, which would be this one right here, which would be this white one right there. That would be your outdoor coil thermistor. And this right here, you want to know what that one is, that would be your LEV, which would be CN724. Right? So that would be it. If you wanted to know where your reversing valve coil, where your reversing valve is, you would find it right here. Let's see, where is it at? Right here. The coil CN 21S4 is CN721, and so you would find it right here. We come over here, CN721, we would know it was right there. So we would just come all the way back to the back here. It was those two pink wires right there is your CN721, and you follow it down, that would be your reversing valve. If you're suspecting a fuse is blown, you could actually find a fuse 801 or the 701. We would have to find 701. And I apologize, I never prep for these videos. I just actually just come out here and just, here's CN7, here's your 701, this fuse right here. We could actually turn power on, and we could take voltage on that pin right there and that pin right there. If you didn't have voltage, we would know that fuse was good. But if you had voltage on one side, that would mean that your fuse was bad. So you would know that that fuse was bad on this board. And if you wanted to check your compressor, if you want to ohm your compressor out, let's go ahead and do it right quick. How do I know where my compressor is? Well, right here, output drive to compressor, LDU, LDV, LVW is right there, and it's right there. So if I wanted to ohm my compressor out, all I would have to do is get my trusty meter right here, put it on ohms. So if I wanted to test the compressor, the ohms, you go from black to white. We got 1.3 ohms, or 1.1. Then we go black to red. We got 1.1 ohms. And then white to red. We got 1.5 ohms. So that's how you test the compressor. If you want to test your fan on this particular one, the fan is a 3-phase motor. And then we just go from the same deal right there, U to V. We got 15 ohms. Got 14.3. And then 14.4, 14.2.